This is a short review of graphing radical functions. In this video, we'll look at a technique of graphing that will ensure we're always graphing integers. So some common values we'll be working with will be things like the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So we're going to make sure that all the values we graph on this video will be integer values, so I don't have to worry about fractions or decimals. We're going to try two graphs. Our first one is just the most basic radical function, f of x equals the square root of x. And I'm going to start by considering the domain. So we've seen together that when square rooting, the value underneath the square root needs to be greater than or equal to 0. Because if the value underneath the square root is less than 0, meaning a negative number, the result is not a real number. So the domain of this function is all values of x such that x is greater than or equal to 0. This would be a good way to write it using set builder notation. Or if you're an interval notation person, you could just tell me 0 included all the way to infinity. So there's the domain. And again, that just came from grabbing whatever was under our square root, setting it greater than or equal to 0, and solving. The reason domain is helpful is this really tells me what value of x to start off with in my table. The domain says all values greater than or equal to 0 are good, so I know if I start with 0, I will be using the furthest left point of our graph, and then our graph will grow to the right from that point. So now, what other values of x should I choose? Well, if I'm strategic, I'm going to choose values like 0, and 1, and 4, and 9 because these are perfect squares. So let's go ahead and use 0, 1, 4, and 9. Really, all we're doing now is we're grabbing these values of x and plugging them into the function. All the function does in this case is it square roots whatever x value we have. So, plugging in 0 means square root 0, in which case we get 0. Plugging in 1, the square root of 1 is 1. Plugging in 4, the square root of 4 is 2. And plugging in 9, the square root of 9 is 3. So we really now have 4 ordered pairs which we can plot. So I'll go ahead and give us a y-axis and an x-axis here. And I'll plot those points in the order they're in our table. So the first point is 0, 0. When x is 0, y is 0. This is essentially the starting point for our graph. I'll just be moving to the right from this point. The next point is 1, 1. And notice if all we had figured out were these 2 points, our function would appear to be linear, but it is not linear. So let's plot a few more. 1, 2, 3, 4 for x corresponds with 2 for y. We can start to see the curve shape forming. And last but not least, when x is 9, 5, 6, 7, 8, 9, y is 3. So let me connect these 4 points, and we now have a basic square root function, f of x equals the square root of x. And that's pretty much it. Please note that I do have an arrow on the right hand side indicating it continues to grow in that direction. However, it does not ever go to the left of the point x equals 0, y equals 0. So that would be our radical function. Let's just try one more. This one gives us f of x equals the square root of x plus 3. And I'm going to ask us again to consider the domain. And the domain in this case is going to be a little different than our first example. Because when I take what's under this square root, which is x plus 3, and I set this greater than or equal to 0, and I solve, it really means to subtract 3 from both sides. So my domain is all values of x such that x is greater than or equal to negative 3. Or if you're an interval notation person, you could also write that negative 3 to infinity. Okay, so I always like to start with this because now I know where to start my table off. I'm going to start with an x value of negative 3. And I know that if I plug negative 3 back into my function, Negative 3 plus 3 is 0, so I end up with the square root of 0, which is 0. So it's starting to feel kind of like our first example. But now I need to pick 3 more x values so that I strategically come up with these nice values for y. I'm going to kind of work backwards here a little bit. I want to end up with a 1 underneath the radical because I know the square root of 1 is 1. I need to end up with a 4 under the radical because the square root of 4 is 2. And if I had a 9 under the radical, that would work out well because the square root of 9 is 3. Okay, so now I have to think kind of backwards. What values of x would make me have 1, 4, and 9 under the radical? So, let's take a look here. If I'm looking at x plus 3, and I'm trying to make that equal to 1, that sounds like x needs to be negative 2, right? Because negative 2 plus 3 would give me back 1. Okay, so that seems to be alright. That's for our second row. Looking at my third row, what value of x would make x plus 3 equal to 4? Well, 1 plus 3 would equal 4, so I'll choose 1 for my next x value. And last but not least, what value of x would make x plus 3 equal to 9? Now I need an x value of 6. So those strategic choices of x can be a little bit confusing, so I do have one more little trick to recommend for you. Let me float back to our other example before I walk you through with this one. In our first example, let me just make a little bit of room. Look at this relationship between the values of x. How did I get from 0 to 1? Or from 1 to 4? Or from 4 to 9? What was added each time? Well, it looks like I started by adding 1, and then I added 3, and then I added 5, and if that pattern continues and I wanted to make my table bigger, I could have added 7 and 9 and 11, so I'm just adding consecutive odds. So that's a nice pattern, but watch that pattern be true in the example we're looking at right now. What did I add to get from negative 3 to negative 2? Well, I added 1. How about from negative 2 to 1? I added 3. To get from 1 to 6, I added 5, and that pattern would continue. So that's just one thing I like to recommend in case you're struggling with building the table. And then let's go ahead and plot these points before we call it done. In this case, oops, I'm going to shift my axis a little bit, make enough space for us. So let me do this right there. There's x. So let's plot the 4 points we have. Our first point this time is negative 3, 0. Our second point is negative 2, 1. Our third point is 1, 2. And the fourth point was 6, 3, 4, 5, 6, comma 3. So you see that same curve shape forming that we saw a moment ago. And when I connect my points, this time my smallest x value is right here at negative 3, and I will grow in the positive direction forever and ever. So that would be the graph of f of x equals the square root of x plus 3. So just to look at our previous example again, notice the shape is the same. The only difference is where it starts on the x-axis. So hopefully that gives you a little bit of help. Please try out some practice.